General relativity, quantum mechanics. One theory is based on gravity and the other is based on anything but gravity. These theories just can't match. Maybe not for long. Enter string theory, but first we need more dimensions. We have 1, 2, and 3. We need more. A fourth bigger one? Well, that's not the case. We need to get smaller, much smaller. Let's say you're on a tightrope. How many directions can you travel? You hopefully said 2, forwards and backwards. But what if we shrink ourselves really small? We noticed we could start going around the circumference of the rope. We discovered an extra curled up dimension hidden to us when we were big. String theory's needed extra dimensions could all be compactified within one dimension, because for the math of string theory to work, we need not 1, not 2, but 9 spatial dimensions. But what is string theory?
Visualize your everyday fundamental particle, like the electron. Now stop thinking of it as a particle, but imagine it as a Planck-scale tiny, one-dimensional vibrating string, with the string being connected to fundamental objects, known as brains.
Now you might ask, what would these strings be made of? The answer to your question? That question is meaningless, because we're talking about the fundamental particles. You cannot get any more basic than this. And string theory is about representing these particles as strings, so these strings can be made of anything. However, they do come in 2 types, open or closed loop. The features of both these types of strings are exactly the same. They're one-dimensional strings, and as they move through space, they leave a 2-dimensional trail, and they store energy by producing stationary waves. But what's interesting is how multiple strings can interact with each other. They can merge up or eventually split up. As it turns out, this separating of strings explains when a fundamental particle decays into a lighter one. And what's even more interesting is how the features of the string determine the particle produced. The length of the string represents the mass energy of the particle, and the vibrational patterns represent the other properties such as spin or charge of the particle. But remember, these are stationary waves. Only certain vibrational modes can be produced. In other words, only specific lengths can produce specific vibrational modes, which will produce specific fundamental particles. Sounds very quantized, right? Well, what if I was to tell you that a new massless particle arises when thinking of fundamental particles as strings? What if I was to tell you that this closed-loop string is free to travel through the many spatial dimensions? I present to you the graviton. This is huge, because if we can prove the existence of the graviton, we prove the existence of gravity in the quantum level. The standard model will now represent all the 4 fundamental forces. Through string theory, a theory of quantum gravity, we might just have found an answer to marry general relativity with quantum mechanics. Through string theory, we just might be able to have our theory of everything.